let's get back to today's lesson. So, okay, you sent me, did you send me your solutions? Did you do this one? Oh, okay. Okay, so these are your solutions.
Yep.
Okay, let's see. Determine the numerical value for QR. Oh, I can see that you actually did it here. I can see, okay, QR. Yeah, I can see that you actually did. You use the Pythagoras theorem to determine the length of QR, correct? Okay. The next one, let me just rotate this thing. Your QR was that, and then now, so you're supposed to determine the numerical value for cos theta, and then I want to see your solution. The adjacent side is 5 over 13, which is also correct. And let's see this one, cotangent, so it's supposed to be 5 over 12. Let's see, 5 over 12. 5 over 12, okay, correct. And then secant of Q angle RP. So this angle here, 13 over 12. So this one is wrong.
Sec.
So sec, what is sec? Sec, it's 1 over cos, right?
Of C.
Of course, right? The reciprocal of cos. So remember, cos of this angle is 12 over 13, right?
Yes.
So it's going to be
Cos
13 over 12. Yeah, you got it correct. Yeah, you're right. Sorry, I'm actually you're actually correct there. Let's see. I want to see something else. Okay, write down the trigonometric ratio that is equals to QR over PR. So it's either sine theta. Yeah, sine theta. Let's look at this one. Okay, what did you do here? You substituted, and then which was 53 minus 34. 53 minus 34, and you also got that 100. And let's see. This is sine square b. Oh, this one is wrong. So here, on this question, for your substitution was actually, you actually used the right thingy. The problem was, you're supposed to say sine of 53 all squared.
Okay.
Yeah, so then this will give you what? Punch this thing on your calculator.
It's 0.63.
0.63. You also put the brackets, right?
Yes.
Not degrees, man. Why do I like degrees? 0.63, not degrees, actually. So now, this one now. This one. I want to see how you did it.
Isn't my answer correct?
For which one? For this one?
3.2.
Oh, how did you get this answer? You squared the angle.
Yep.
No.
I did double brackets, right?
No, let me check something. Sine of 53 all squared, 0.6. Now, yeah, your answer is actually correct, but this step here, this was the step that was misleading me. Nah, your answer is actually correct. So don't put it this way, because they will mark it. They will say it's incorrect. Nah, put it this way. Nah, put it this way, and then yeah, your answer is actually correct. And then now let's go to this one. How did you do this one?
From special angles.
From special angles. I saw you do your special triangles. Okay, there are special triangles. So we'll start with cosec. Cosec, it's sine, right? Is the reciprocal of sine. So we know that for 45, it's going to be 1 over that, so it's going to be root of 2. So correct for this one. And then for sine of 60, it's root of 3 over 2. Root of 3 over 2, correct. And then for sine of 45 is going to be 1 over root of 2, which is that. And then for cos of 30 degrees, is going to be 1 over root of 2, which is also correct. which is equals to, this is equals to what? Or
Is equals to
it's equals to 2. Correct. 100. This is actually good. I won't lie, this is actually good. This is good work. So now, since while we did this and this, in today's lesson, I want us to look at something else.
yes.
Trig identity, trig functions. So now, I want us to look at this question. We're given two trig graphs, f of x, which is sine, and g of x, which is cosine. Ne?
Yeah.
So the first question says that determine the value of p and q. What is p? And what?
Isn't P? Can you zoom?
Okay. Yeah, I'll zoom just now. Can you see?
So yes.
Okay, wait.
So P will probably say is A.
A, right?
Yeah.
The amplitude, right?
Mm-hmm.
Okay. So what is the amplitude of f of x? The sine graph.
The amplitude of x.
Yes.
It's positive 2.
It's 2. So it's the distance from here to here, right?
Yes.
The distance from here to here. So the amplitude for this one, so P is going to be equals to 2. 1 mark. So now let us look at Q. What is Q?
Q, let me see. X, let's see. It's C.
What is C?
C. I'm not sure because it's mostly U.
So C is actually the horizontal shift. Either the graph have to move upwards or downwards. Ne?
Yes.
Yes. So I would like us to look at something here. Before we dive into that, ne? I want us to look at something here. We have a function of sine. Remember, a sine function starts at 0, and then it goes to 90, and then goes to 180, 270, then 360, right? Yes, something like that. So yeah. So this is the same graph. So how will the cosine graph look like?
So this is the same graph.
Yeah, this is the same graph.
So it's positive.
It's going to start here, and then it's going to move this way, then come here, turn here, go there, and then end this way. This is a cosine graph.
Yes.
So this is a mother graph of a cosine graph, and that's the black one is the mother graph of the cosine graph. So actually, a cosine graph, it starts at 1, goes to 0, goes to -1,
Yes.
right? And then comes back
Yes.
again. So let's go back to this. Let's go back to this question here. We can see it's a cosine graph. You can see the shape, right? You can see the shape.
Yes.
It's a cosine graph. So now what happened to this cosine graph? Remember, the mother graph has to go from here to here. Then, okay, no, I made a mistake there. Go to here again, and then come back, go here, and then turn that way. So this is the mother graph of the cosine graph, right?
Yes.
What happened to this graph?
It increased by 1.
It shifted upwards by 1.
Yes.
Shifted upwards by 1. So that's the transformation. So what is Q?
Q is it the shift?
Yeah, the shift. So what is Q equals to now?
Q equals to 1.
Q is equals to 1. Another mark. So 2 marks. So now the question says, write down the amplitude of G. Can you write down the amplitude of G? What is the amplitude of G?
The amplitude of G. It's positive 2.
Positive
From
2.
0. Yes.
So unfortunately you are wrong.
How so?
So the amplitude, you go here. Remember the amplitude? It's here. Remember I said what is Q?
Oh, okay.
What is Q?
You said the Q is 2.
It's 2. So what will be the amplitude of sine?
The amplitude of sine is going to be positive 2.
It's going to be positive 2. So therefore, what is the amplitude of cosine?
amplitude of cosine is 1.
Amplitude of cosine is going to be equals to 1 unit.
1.
1 unit. So basically for this one here, our amplitude is going to be 1. So I want you to focus on these things here. I'll write something. Let me write the notes for you here. So I just want you to check on something. We have A cos x plus c. Ne?
Yes.
This represents the amplitude. This represents the horizontal shift. So I want you to check. So I'm going to write it here. Amplitude, vertical shift, or up or downward shift.
But what does B stand for?
Open bracket,
Bx
bx
plus c
plus c,
close bracket
close bracket,
plus d.
plus d. So there's maybe cos bx plus c plus d.
Yes.
And then
But
maybe
there's an a before
a.
the bracket.
Or there's something, or it's something like this, ne?
Yes.
Okay. Or you want this b
No, the d.
or the d. So the d is actually the same. D doesn't change. D actually represents vertical shift or up or downward shift. They can change alphabets, it doesn't matter, but whenever you see plus d or minus d, that's just know vertical shift or up or downward shift. So I'm just going to so you guys discuss what is this. Did you guys discuss what is this?
Yes, that's the period.
That's the period, right? So
yes.
How do you get the period?
You minus the right value with the left value.
Mm-hmm.
Then you get another equation is 360 over absolute value of b.
360 over.
Can you say period is equal to?
Yeah.
Can you say p is equal to?
P is equals to
360 over the absolute value.
The absolute value of
b.
The absolute value of b. So I want you to check on something here. There's something I want to discuss with you now. What does that actually mean? Ne? Let's say, for instance, they ask you. Maybe let me check whether they did ask you. No, they didn't. Let's say, for instance, they ask you, what is the period of this function? P sine x.
P sine x. If I want to find
the period.
I'm gonna say 360 minus 180. 360
minus 180. That's not actually how you find the period. You know how do you find the period?
Let me finish first.
Okay.
Since the starting to minus 180 into 180, then I'm gonna substitute add that equation that I told you.
Mm-hmm.
P is equal to 360 over the absolute value of b.
Mm-hmm. What is the absolute value of b?
We haven't found it yet. But then I'm going to substitute p.
What is p?
P is 180.
P is 180.
Then cross multiplication.
Cross multiplication. Oh, this is p. This is p. Sorry, this is p. Cross multiply. So it's going to be what?
180b.
Mm-hmm.
Equals to 360.
360.
Then divide by 180 both sides.
Divide by 180 both sides. What is p?
So b is equals to 2.
Is equals to 2. So this is wrong.
Yeah.
You know where did you make a mistake?
Where?
You actually made a mistake here.
Yeah.
Let me show you something. When they are talking about the period, the period of the wave, you look at the complete wave. Remember, a wave is made out of two pulses, right? There is the first pulse and the second pulse, right?
Yes.
So what is the period of this wave?
The first pulse and the second pulse.
Mm-hmm.
So If I'm the first pulse, anyway, it cuts at 180.
It's 180, and the second pulse?
It's 360.
360. So what is the complete period of this wave?
It's 180.
Nope. The complete period, it's 360. So for it to be a complete wave, the period of this wave is going to be 360. Do you get it?
What's the thought?
Yeah.
Isn't the period the time taken?
Yeah. Yeah, that's the time it takes for the wave to complete.
Okay.
So remember, if you are saying the P is actually 180, you are telling us that the wave actually ends here, whereas this is not true. This wave actually ends at 360. Do you see that?
Yes.
So the period of this wave is 360. Ne?
Okay.
So you're going to substitute 360 here. You're going to substitute 360 here, and then don't forget that, because most of you guys make a mistake there. Always check the wave. Where does the wave actually end? Ne?
Okay.
And then you are going to cross multiply. You're going to cross multiply. So this is going to be 360. And then what is your B? Your answer is going to be 1. Which is, this is true. Let's look at the period of this wave. The period of this wave is 1. Look at sign here. Here, next to x here. Next to x, there's actually a 1 here. That is there.
Oh, okay.
That is actually...
Is it because there's only one wave?
There's only one wave. There's only one complete wave. Remember, for sine, the period of the mother graph, the period of the mother graph is 360, right? Which is this 360 here, right?
Yes.
And then this period here is not the period of the mother graph, but is the period of the given graph. And then the period of this given graph is 360, as we can see from this diagram, right?
Yes.
That's why we're getting 1 at the end. Do you understand what I'm talking about?
Yes.
Can you tell me what is the period of cos x? Can you calculate it for me? What will be the period of cos x?
Can I go to cos?
Okay.
See. So B is equals to 1.
B is equals to 1, which is true. Which is true. Whenever we can see here, we can actually see that here, next to x here, there is a 1 there that is missing. That is actually there. That is actually there. So you're actually correct. You're actually correct. So now, our next question is, write down the range of f.
Okay, let's see which one is F. F is the same graph.
Yeah, it's the same graph.
Okay. So we say that the range is included -2 and included +2.
Included -2 and included -2. 100. So you'll say y, an element of included -2 and included +2. And then, now, for which values of x will f of x be greater than 0?
And the values of f of x.
Will f of x be greater than 0? Did you do it?
So if I substitute, it's gonna be 2 cos x.
It's 2 sin x. Remember, we are using
sin
x.
So let's say say shift in sin 0. So x is greater than 0.
X is greater than 0.
Yes. The way I did this divided by 2 on both sides.
Yeah. Yeah, I can see what you actually did here.
Okay.
So I want to teach you something that maybe they didn't actually teach you, ne?
Yes.
So I want us to use the same method that you are trying to use here. But for now, remember, yeah, we're going to stop there. We actually got x equals to what? X equals to 0, right?
Yes.
X equals to 0 degrees as your reference angle, right? This is your reference angle. Okay. And then we can actually see that 2 sin x is greater than 0, meaning 2 sin x is positive, right?
Yes.
Okay. Now we are going to draw our cast. we're going to draw what you call a cast. And then we are going to check something here. Where is sine positive?
At the left side.
Where is sine positive? Here, in this quadrant, and this quadrant, right?
Yes.
So sine is positive from 0 degrees to where?
To what is?
It's sine. Remember cast. You know what is cast?
No.
Oh, okay. So cast is another thing that we use in trigonometry. So I want us to discuss what is cast. I thought maybe you knew what is this. So we're going to draw something like this, and then in this quadrant here, this is the first quadrant, right?
Yes.
This is the first quadrant. So all trig ratios are positive, ne?
Yes.
And then this side, only sine is positive, ne?
Yes.
And then here, only cos is positive. And then on the fourth quadrant, here only tan is positive. No, I'm making silly mistakes. So here only tan is positive, and this side only cos is positive. So that's where cast actually comes from, ne?
Yes.
So here it's C. It's C-A-S-T, cast. Can you say it?
It's a C.
C-A. We only take the first letters. So the first letter of course is C, and then the first letter of all is A, and the first letter of S is S, of sin is S, and the first letter of pan is T. So it's cast. Or we can say all students take coffee. You know this?
All students take coffee.
Have you heard it from somewhere?
No, just heard it now.
Okay, so we are going to use this. Sine. Remember, we already know that we measure angles clockwise, right? So this is 0 it starts here, it says 0 degrees, and then here it's going to be our 90 degrees, and then here it's 180 degrees, here is 270 degrees.
Oh, then I'll say 360.
And then here you say 360 degrees. Have you seen something like this before?
Yes.
Yes, it's something like this. So in this quadrant, all trig ratios such as sine, tangent, cosecant, cotangent, they are all positive here on the first quadrant. Ne?
Yes.
And then on the second quadrant, only sine is positive. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant.
Yes.
So according to here, remember I told you that when you see greater than, just know we are looking for the positive side only, right?
Yes.
And then we can see that from 0 degrees, ne?
Yes.
And then going this way up until 180 degrees, sine is positive. So here we can conclude that we can say x from 0 degrees up until 180 degrees, sine is positive.
Yes.
You understand it?
Yes, I do.
Yeah. So we can use also another method. We can also use another method. This is method number 1. So method number 2. Method number 2 will be using the graph. So now this method is called graphical interpretation. Eh?
Yes.
So we go back to our graph. We'll look where sine is positive. So we'll look where sine is positive. We can see on this side, sine is negative. You can see that it goes on the negative side here, and then this side it goes on the positive side, right?
Yes.
So we can see that sine is positive from 0 degrees going up there up until 180 degrees. Can you see that? So this part here, sine is positive, right? So we can conclude that for x in between, remember we check the sign. Always check the sign. If they said greater than or equals to, that's when you put the equal sign, right?
Yes.
So you'll say x is positive only from 0 degrees. Remember, from 0 degrees up until 180 degrees. So you put 180 here. So there are two ways to kill a cat. there's this way, and then there's also this way. So you'll choose the one that you like the most. Ne? Okay. So now let's look at question 6.5. Can you read the question?
The graph of G is reflected about the x-axis and then shifted 2 units upwards to obtain the graph K. Write down the equation of K.
Write down the equation of it's H, ne? It's not K, it's H.
Oh, it's H.
Yeah. So now let's look at G. Let me just erase these things. This mess here. First part, it says what? Can you repeat it again?
The graph is reflected about the x-axis.
About the x-axis. Let's stop there. Let's stop there. Let's just stop there. What do they mean when the graph is reflected about the x-axis?
And if it's reflected, it will change. It will be negative.
Close. Very close.
And the first one I'm gonna sit down, the other one face up.
Very close. Very close. Okay. I think you are quite there. You're actually telling me something that I wanted to hear. You said what?
I'm just thinking from being positive it's gonna be negative. When it's shifted about the x, it's reflected.
Mm-hmm.
About the x-axis.
Mm-hmm.
So it's gonna change. You see this first pulse.
This first pulse. Okay, this first pulse. I can see it.
So it's gonna change.
It's going to go it's going to go this way, right?
Yes.
And then after it goes this way. And then after it goes this way. Yeah, something like that. So what does this actually mean? What are they trying to tell us here?
That it has been reflected. But
it has been reflected about the x-axis. What are they trying to say? No, I think I made a mistake here. It's been reflected. It's going to be something like this. Sorry, I think I made a mistake. So remember, we're going to check the x-axis. We're going to check the x-axis. So we're going to reflect the graph according to the x-axis, right?
Yes.
So it's going to go this way, and then up there. Yeah, you get it, right?
Yes, I was surprised when you reference here.
Yeah, I don't know, but is this match is stressing me because he's not winning. So it's going to go something like this. Remember, we're looking at the x-axis, right? So something like this, right? So it's reflected about the x-axis. So what happened here? I want us to just tell me something. Just tell me a scenario. What happened actually here?
It changed from being positive to
Negative. So this actually tells us that this function of g here, it was positive g of x. Now it's changed to what? To negative
G of x.
To negative g of x. You understand what I'm trying to say, right?
Yeah.
So now we are going to substitute what is our g of x. What is our g of x?
Our g of x is gonna be negative cos x.
Negative open bracket cos x.
Plus q.
And then what is our q?
Our q is... What is our q?
What is our q? Our q is 1.
Okay.
It's 1.
Our q is 1.
So plus 1 here. Put our plus 1 here. And then now we are going to multiply everything with this negative. So it's going to be what?
Negative cos x.
Negative cos x.
Plus minus 1.
Minus 1. So this is our new function if it's reflected about the x-axis, right?
Yes.
So now, what are they telling us now? They're telling us that they're telling us something else now. They're saying that, okay, we understand the first part, right? We understand the first part. So can you read the second part?
Then shifted 2 units upwards.
2 units upwards.
To obtain the graph H.
Yeah, let's stop there. Shifted 2 units upwards. What does that tell us?
Meaning It was shifted and I started 0.
What happens? This graph now, it's shifted 2 units upwards. Now it's going to start at 0. It's going to be whatever that I've just drawn. I don't know, maybe I was predicting the future or what. So it's going to be something like this, and then going that way, and then going this way, right? It's going to be the red graph, right? So it shifted by 2 units upwards. So what happened here? We are going to plus by 2. Do you understand?
Yes.
We are going to plus by 2. So our new graph, this red graph, the h of x, is going to be what?
Negative cos x minus 1 plus 2. Or we can say plus 1.
Plus 1. Plus 1. So this is our new function. Remember they are saying write down the equation of h. So this is our equation. This is our equation of h. The h go, yeah. This is our new equation of h. Yeah.
Okay, and I understand it now.
Okay, I wanna give you. I want us to try a question similar to this one, but I'll give you 30 minutes or 20 minutes to do it. Sundown's almost called, bruh. Yeah. Of course, yo, bruh, yo. That was a very close one. As that one. So yeah, I want you to do this question. It's exactly the same as that one was.
Okay. It's gonna be easy.
Yeah, this is going to be. So okay, what was the value of a?
The value of a was 1.
Was 1. So this was 1. And then determine the range of g.
The range of g is positive 2 and negative 1. Included 2.
Positive 2 and what?
And negative 1.
And negative 1. That was wrong. So let's look at the range. So g is actually moving from 2, positive 2 to 0.
Oh,
so
I used the wrong graph. Okay.
Yeah, so g is from 0 to 2. Determine the amplitude of g.
The amplitude of g is 1.
Is 1. For which values of x will g of x be greater than 0? What did you use? You used the graph method or the other one?
I got x equals to 1 or x equals to 19.
Let's look at f of x. We are going to start here. We are going to look at f of x, this line, and then we are going to look at this line. Which one is greater than the other one?
Cos is greater than psi.
Yes. So f is actually less now, ne?
Yes.
It's less. So this one doesn't apply. So this one is not included. So we are going to go to this portion here. Now let's look at, this is f, right?
Yes.
And this is g. Which one is greater than the other one?
F is greater than g.
So we can see that the values of x from 90 degrees to 180, f of x is greater than g of x. You can see that, right?
Yes.
So we can see that x from 90 degrees to 180 degrees, f of x is greater than g of x. So I would advise you, for this kind of questions, always use the graphical method, ne?
Okay.
So don't use the critical value method, use the graphical interpretations. So this was supposed to be your final answer. You can see that, right?
Yes.
So we can write it here. X, it's in between 90 degrees and 180. So now here comes a very nice question. So it says g of x minus f of x is equals to 2.
Yes.
Where g of x minus f of x is equals to 2.
So what method do you use?
Let's also use the graphical interpretation method. So we are going to start I'm going to show you how easy is the graphical interpretation method. Ne? All you have to do is just look at the graph and then. So we are going to start here. They said f of x minus g of x, right? Has to be equals to what? 2, right?
Yes.
Yes. So we can see that f of x here is 0, and then g of x here is what? 2.
2.
So what is 0 minus 2?
0 minus 2 is negative 2.
Is negative 2. So that doesn't apply, right?
Yes.
So this doesn't apply. And then here they are equal. So here it's 1 and 1, which is 0. And then also here they are equal. Then we are going to go to the other part. Here, this is the graph of what? This is the graph of f, right?
It's the graph of fx.
Of f. So what is f of x equals to here?
It equals to negative 1.
Negative 1 minus. What is? Minus what?
Positive 1.
Positive 1. And then what is that equals to?
Negative 2.
Negative 2. So this doesn't apply. So this doesn't apply. And then we go here. What is f of x equals to here?
0.
0 minus?
Minus 2.
Minus 2. So I want to see something. Oh, we actually did vice versa. It's actually g of x minus f of x, not f of x minus g of x. Ne? So let's start again. Let's start afresh. I'm going to show you how easy. You saw how easy it is, right?
Yes.
All you have to do is just subtract. So we are going to say 2 minus. It's going to be 2 minus 0, which is what?
It's going to be 2, positive 2.
It's going to be positive 2. So we can see that here our final answer is going to be something like x element of, and then we are going to put the curly brackets, going to say 0 degrees. Remember, at 0 degrees it's equals to 2, right?
Yes.
Then we are going to look for the other one. And then always put the curly brackets. Remember, we have multiple values of x, right?
Yes.
And then here obviously it's 0, and here obviously 0. And then coming here now, we are going to say g of x. What is g of x?
G of x. G of x is 1.
1 minus, open bracket,
1 minus negative 1.
Minus negative 1, which is equals to?
2.
Which is equals to 2. And then we can see that x is equals to 270 right here, right?
Yes.
And then we are going to go here. Going to go back here. Going to put 270 here. 270 degrees. Then we are going to look for the other one. The other one we are going to, it's going to be 360. So what the fuck is happening here? Okay, 360 degrees. Just like that. So it's 3 marks. You can see that it's 3 marks, and then we have 3 values of x. You can see that, right?
Yes.
So it's 1 mark for each value. If maybe you only wrote 0, you will get 1 mark. If you wrote 0 and 270, you'll get 2 marks. But if you got all these 3, you'll get full 3 marks. It was a tricky one, eh?
Yeah, I did not expect it, but yeah, I understand it now.
Yeah. So now, the graph of f is reflected across the x-axis. Write down the equation of the new graph h.
That's easy.
That's child's play. What was the new graph?
It's negative cos
H of x. Okay. H of x is equals to negative cos x
plus 1.
I want to see whether it's plus 1 or minus 1. I'm not quite sure there. So remember, you multiplied by negative, so it's going to be negative, open bracket. Yeah, it's going to be cos x
negative 1
plus 1. And then the negative will multiply, giving us negative 100. So always be careful there, because if you wrote plus 1, your answer is wrong.
That's net.
Yeah, that's maths error for them. So 1 mark. So that's it about trig functions in grade 10.